So in this case, if p is equal to 1, the limit, sorry, here we will not use the equivalence. We have only two cases. If this is equal to 0, if p is greater than or equal to 1, and it is equal to, it is not defined if p is equal to 0. So what remains is, so our function, our function f is continuous if and only if alpha is equal to equal to 0. Otherwise it is not, because the limit of f of x is equal to 0 when x approaches 0, and should be equal to f of 0, which is equal to alpha. Now we will pass to the next exercise. So this is exercise. Now the next exercise. So here find the parameters, find the value of a and b to make the function f continuous over the given interval. So here we have the function f of x is equal to the following function: minus 2 sine x if x is less than or equal to minus p over 2. Next, a sine x plus b, a times sine x plus b, if x is between these two values, minus p over 2 and p over 2. Here we have strictly less and strictly bigger, and it is equal to cosine x if x is greater or equal than p over 2. So the functions sine x and cosine x are continuous on all r. So minus 2 sine x is continuous on this interval, on x belongs to the interval from minus infinity to minus p over 2, open, and a sine x plus b is also continuous on the interval x in the open interval minus p over 2 to p over 2, and the function cosine x is continuous on the interval where x is greater than p over 2 to plus infinity. What remains is to study the continuity on those 2 points, minus p over 2 and p over 2. So the limit when x approaches minus p over 2 with less from the left of f of x is equal simply to the limit when x goes to minus p over 2 of minus 2 sine x minus 2 sine x, which is in this case equal to minus 2 sine minus p over 2, which is equal to 2 sine p over 2, which is equal to 2. Now next, limit of x goes to minus p over 2 with from the left, from the right. So it is equal to the limit when x goes to minus p over 2 of the second function here from the left of minus p over 2, x belongs to this interval, so f takes this value. Here x is in the interval minus p over 2 to p over 2. So here we have a sine x plus b, which becomes a times sine minus p over 2 plus b, which is equal to minus a sine p over 2 plus b, which is equal to minus a plus b, so it is equal to b minus a. Hence, so for the function to be continuous, we should have limit from the left is equal to the limit from the right. Limit of f of x is equal to the right limit of f of x. X goes to minus p over 2 with from the right, and here x is going to minus p over 2 from the left. This value is equal to 2, and this value is equal to b minus a. So this is the first equation. Now we will calculate the limit from the left and right of p over 2. So the limit when x goes to p over 2 of f of x with from the left is equal to the limit when x goes to p over 2 of a times sine x plus b, which is equal to a sine p over 2 plus b, which is equal to a plus b. And the limit when x goes to p over 2 from the right of f of x, here it is equal to the limit of cosine x, because f of x here x is belongs to the third interval where the function is equal to cos x, which is equal to cos sine of p over 2, which is equal to 0. So this implies that these two values should be equal. So a plus b is equal to 0. And this is the second equation. So we have a system of two equations. A minus b is equal to, minus a plus b is equal to 2, and a plus b is equal to 0. So in this case, b is equal to minus a, and we replace in this first equation, we find minus a is equal to 2. So minus 2a is equal to 2. So a is equal to minus 1. And here, so means that b is equal to 1. Hence, f is continuous if and only if a is equal to minus 1 and b is equal to 1. Now we will go to the next, we will pass to the next exercise. Determine whether the given functions can be extended to continuous functions. We have 4 functions. We will study if they are we are capable to extend those functions. So we pass to a new exercise here. A new title. Extension by continuity. So this exercise means كيفاش نديرو امتداد لدالة على مجال أوسع. مثال من مجال R ناقص القيمة 0، نوسعها الدالة هذه تولي معرفة على المجال R. بصح مش نوسعها برك، نزيدو نعرفها على سيتادير نعرفو f of 0 بحيث الدالة تاعكم تولي continue on all of R. سيتادير نمدو مجال التعريف تاعنا باش تولي الدالة معرفة على R وتبقى مستمرة. في الحالة هذه عندنا قداش فونكسيون. الفونكسيون الأولى هي f of x is equal to 1 over x sine 1 over x. So this function is defined on, so this function هذه الدالة, this function is defined on R minus 0, because f of 0 is equal to 1 over 0 sine 1 over 0, which is not defined. Otherwise the function on R minus 0 f is continuous. So the question is it possible to define f on R and make f continuous on all R. So this is the question. To do this, we must have that the limit when x approaches 0 of f of x should be equal to f of 0. So we should define f of 0 such that f of 0 is equal to the limit of f of x when x approaches 0. How to do this? We should calculate the limit. So the limit when x approaches 0 from the left of 1 over x, which is f of x, 1 over x sine 1 over x. Notice that sine 1 over x oscillates between those two values, minus 1, 1 and minus 1. Okay, and therefore, and by multiplying by 1 over x, we find that minus 1 over x, here 1 over x is greater than 0 because x is positive. Here we are dealing when in the case when x is positive. So 1 over x is positive, so when I multiply, I do not flip the side of the inequality, so it remains like this. One over x. Now, in this case, this part will goes to minus infinity when x approaches 0, and this part we don't know where, and this part will go to plus infinity. So now, who has an idea on the limit of this function when x goes to plus to 0? Do you have any idea? So this limit does not exist. Why? Because we can define two series xn is equal to 1 over here p over 2 plus 2pn, and yn is equal to 1 over 2 3p over 2 plus 2pn. In this case 1 over xn in this case xn is going to 0 when n is going to plus infinity, and yn is going to 0 when n is going to plus infinity. So 1 over n xn and 1 over yn both are going to plus infinity when n is going to plus infinity, and sine 1 over xn is equal to sine 1 over 1 over p over 2 plus 2pn, which is equal to sine of p over 2 plus 2pn, which is equal to sine p over 2, which is equal to 1. So sine 1 over xn will converge to 1 when n goes to plus infinity. And with the same way, sine 1 over yn is equal to sine 1 over 1 over 3p over 2 plus 2pn, which is equal to sine 3p over 2 plus 2pn, which is equal to sine 3p over 2, which is equal to minus 1. Hence, so the limit when n goes to plus infinity of 1 over xn times sine 1 over xn is equal to plus infinity times 1, which is equal to plus infinity. At the same time, the limit when n goes to plus infinity of 1 over yn times sine 1 over yn is equal to plus infinity times minus 1, which is equal to negative infinity. Those two are not equal, so by the sequential characterization of the limit this limit 1 over x sine 1 over x does not exist. Hence, f cannot be extended to a continuous function on all R. Is it clear؟ مفهوم؟ هل كاين هناك سؤال على التمرين هذا؟ اللي ما فهمش يبوزي لا كاستيون. So next we will pass to the next one. The next question is f of x is equal to